Hello there, this is Ms. Nakayama, and today's lesson is 9.2, the Pythagorean Theorem. And I'm thinking that y'all already know this, so I'm going to go through it really quickly, but write down any questions that you might have. But remember, you can slow me down if I'm talking too fast. So first off, you've got your basic Pythagorean Theorem that tells you if you have a right triangle, then the square of the leg of the hypotenuse is equal to the sum of the squares of the lengths of the legs. That's in words, which is why we use symbols in math, because it's a lot easier to say a squared plus b squared equals c squared. Y'all know that. What you really need to remember is that c is the longest leg of the triangle, and it always has to be by itself. All right, that longest leg is going to be opposite the right angle. Okay, so that's in case you can't tell. All right, the converse of the Pythagorean theorem, y'all, says if I have a squared plus b squared equals c squared, then I know that ABC is a right triangle. So we have Pythagorean triples, and those are sets of non-zero whole numbers that satisfy the Pythagorean theorem. So here are some examples of common ones: 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, and 25, and any multiple there are. If you look in this first one, 3 times 2, 4 times 2, 5 times 2. So 6, 8, 10 is another common one. If you know these, it makes calculations a lot easier for you, okay? But one of the things to keep in mind on our Pythagorean triples is that they are all whole numbers, y'all. So they're not fractions, they're not decimals, they're not square roots. They have to be whole numbers to be considered a Pythagorean triple. All right, one last thing before we do some examples, and that is our Pythagorean inequalities theorem. And that tells you, y'all, I remember this, but I remember the one that's by itself, okay? If c squared is less than, then my triangle is going to be acute. And if c squared is larger than a squared plus b squared, then it will be obtuse. So if you remember it in regards to the one by itself, small, acute is small. So if that one by itself is smaller than, then you have an acute triangle. It's easy to remember the theorem. Okay, so let's look at the examples you're going to have. So we have a triangle with our hypotenuse is x. And that means when I write my equation, x squared needs to be by itself. So 4 squared plus 5 squared equals x squared. When I add those together, I get x squared equals 41. I'm going to take the square root of both sides. And one of the things you might not be familiar with, when you take the square root of an equation, there's a plus or minus. I know you've heard of it before, but a lot of times people forget to write this, and then they forget it when they really need to. So, however, we're in a triangle, so x is going to be just the square root of 41. All right, look at number 2. Oh, actually, before it says find the value of the variables, then tell whether the sides form a Pythagorean triple. Well, if one side is a radical, then this does not form a Pythagorean triple. All right, next, I have x is opposite my hypotenuse. So x is the hypotenuse. It's opposite the right angle, so it needs to be by itself in the equation. So I have 12 squared plus 35 squared equals x squared. X squared equals 1369. And the square root of 1369 is plus or minus 37. So x equals 37. That means my side lengths are 12, 35, and 37. So that is a Pythagorean triple. All right, number 3. Right there, y'all, the answer is does not form a Pythagorean triple. Has to be a whole number. But 11 is going to be by itself. So I'm going to have x squared plus the square root of 115 squared equals 11 squared. If you're using a calculator, y'all, you need to make sure you put it in the calculator correctly. So x squared is going to equal, well, I'll go ahead and write it out. X squared plus 115 equals 121. X squared equals 6, and x equals plus or minus the square root of 6. Somehow I missed that. Oh, well. You know what? That's because y'all aren't here. There's supposed to be a square root here and a square root there. So make sure you put that on your paper. And as I mentioned earlier, there's no Pythagorean triple. Number 4. Oh, we have 2 x's in this one. 12 is the hypotenuse, so it needs to be by itself. So I have x squared plus x squared equals 12 squared. That's 2x squared equals 144. X squared equals 72. And that means x equals, I can make it bigger for us, x equals plus or minus 36 times 2, because that's what 72 is. Square root of 36 is 6. So x equals 6 square roots of 2. And again, there's a radical in that side of the triangle, so it is not a Pythagorean triple. All right, number 5. I have the one, so really the key, y'all, when you're doing this, you always want to make sure you know which one's opposite the right angle. Which one has to be by itself? 25. So I've got 15 squared plus x squared equals 25 squared. And 225 plus x squared equals 625. X squared equals 400. X equals plus or minus 20. So x equals 20. And all of those sides are whole numbers, and they satisfy the Pythagorean theorem, so that is a Pythagorean triple. 15, 20, and 25 is a Pythagorean triple. All right, number 6. Okay, y'all. If they tell me this whole side length is x, that means that this part right here is just half of x. So when I put it in, 12 is again my hypotenuse, so I'm going to have 1/2 x squared plus 10 squared equals 12 squared. And 1/2 quantity squared is 1/4 x squared plus 100 equals 144. I chose to go ahead and subtract 100, so 1/4 x squared equals 44. X squared equals 44 times 4. I didn't want to pick up my calculator because I'm going to take the square root of both sides, and that's x equals the square root of 11 times 4, which is 44 times 4. Well, there's a perfect square, so it's going to be 4 square roots of 11. That's the side of my triangle. You know what? That's x. That's true. That is x, because that's the way I set it up. We do not have a Pythagorean triple, because that's one of the sides. Okay? Now, look at number 7. We have a right triangle in there, but it is part of this trapezoid. So to find x, I need to look at just this this right triangle. So what I need to find is, first of all, I got to figure out what this little piece is right here. Oops, I didn't mean to do that. That little piece right there. And if you can see that the whole side is 18 square roots of 2, and then this side is 16 square roots of 2, then I subtract those two, I will get the length of that side. So that means that my Pythagorean setup, I still need the other side. I need this side, which we can get by seeing that it's going to be the same length as 8 on the other side. So my setup is going to be that x squared equals square root of 2 square roots of 2 squared plus 8 squared. Okay, that is 72. So x equals plus or minus the square root of 36 times 2, and x equals 6 square roots of 2. Okay? Number 8 is a weird shape, but x is up here, and x, we have these tick marks telling us that that's going to be x, and that's going to be x, and that's going to be x. So my setup is going to be that x squared plus x squared equals 11 square roots of 2 squared. So 2x squared equals 121 times 2. Divide both sides by 2, and x squared equals 121. And x equals plus or minus 11. But I'm in a triangle, so x equals 11. And now I'm going to take that information to go find this triangle. So x is 11, so I'm going to have 11 squared plus n squared equals 12 squared. That's 121 plus n squared equals 144. N squared equals 23, and n equals plus or minus the square root of 23. So n equals the square root of 23. So several examples for your Pythagorean theorem. Now let's go determine whether or not we have a right triangle. So when you're doing this, you got to make sure you know what this is. So put it in your calculator if you have to. It's about 8.9. So I do know that 12 is the longest side of my triangle. And so I'm going to set up 8 squared, find out what 8 squared plus 4 square roots of 5 squared is. And when I simplify the left and the right, I find out that they're both 144. So that means that, yes, this is a right triangle because it satisfies the Pythagorean theorem. All right, look at number 10. We have 9, 14, and 2 square roots of 30. I don't know if you're sure, but if you're not sure, put it in your calculator and you'll find out that 2 square roots of 30 is about 10.5. So 9 squared plus 2 square roots of 30 squared. How does that relate to 14 squared? Is it equal? Well, on the left I have 201 and on the right I have 196. That is not equal, so I do not have a right triangle. Okay, these 11 and 12 just want to know if they form a Pythagorean triple. So I'm going to put it into the Pythagorean theorem. 5 squared plus 12 squared equals 13. Or you could know your Pythagorean triples. And 5 squared plus 12 squared is 169, which is what 13 is. So yes, that's a Pythagorean triple. 4, 9, and 12. 4 squared plus 9 squared, does that equal 12 squared? Well, 4 squared plus 9 squared is 97, and 97 does not equal 144, so that is not a Pythagorean triple. All right, find number 13, find the area of the isosceles triangle. So I'm sure you remember your isosceles triangle theorem that tells us when we drop an altitude from the vertex angle of an isosceles triangle, it bisects the base. So that means each of these is 8. So if I need to find h to find that area, then that means that 8 squared plus h squared equals 17 squared. 64 plus h squared equals 289. H squared equals 225. And h equals plus or minus 15, so h equals 15. But I have to find the area. And the area of a triangle is 1/2 the base times the height. So my base is 16 and my height is 15. So when you multiply that out, you get 120 square meters. All right, few word problems and then we're done. The lengths of the sides of a triangle are given. Classify each triangle as acute, right, or obtuse. Not exactly a word problem, but we'll take it. So, I'm going to, again, sorry, don't know why that happened. I'm going to start with the two smaller ones. So I'm going to do 7 squared plus 8 squared. How does that relate to 9 squared? Well, 7 squared plus 8 squared is 131. 9 squared is 81, 113. So 113 is bigger. So remember, this is the one that I said, look at C by itself. If C squared is less than the other two, then I have an acute triangle. Okay, 14, 15, 11. Don't get suckered up, y'all, but the two shorter sides are 11 and 14. So I'm going to do 11 squared plus 14 squared. How's that relate to 15 squared? 11 squared plus 14 squared is 317, and that is greater than 225. So again, C squared is less than, so it's acute. All right, and look at 16. So if you don't know, the square root of 3 is 1.7, so that's the smallest. So I am going to do them in that order. So I'm going to have the square root of 3 squared plus 2 squared. How does that relate to 3 squared? Well, 3 plus 4 is less than 9. And this time C squared is bigger than the other two, so that's going to be obtuse. And we know, of course, if it's equal, it's a right triangle. All right, this says verify that the segments, number 17, verify the segments with lengths 3, 4, and 6 form a triangle. Is the triangle acute, right, or obtuse? So how do I verify they form a triangle? I make sure the two smallest are add up to be bigger than the third. Well, in this case, 3 plus 4 is larger than 6. So now I'm going to do 3 squared plus 4 squared. How does that relate to 6 squared? Well, 3 squared plus 4 squared is 25. 36 is bigger than 25, and so that means I'm going to have an obtuse triangle. All right, number 18. Jamal leans a 12-foot long ladder against the side of a house. The base of the ladder is 4 feet from the house. To the nearest tenth of a foot, how high on the house does the ladder reach? So, a lame attempt, oops, that's not what I wanted, at drawing. Here's my house. Here's my ladder. My ladder is 12 feet. The base of the ladder is 4 feet from the house. And to the nearest tenth of a foot, how high up the house? So I'm looking for that length x right there. That's part of the house. So my Pythagorean theorem would tell me that 4 squared plus x squared equals 12 squared. That's 16 plus x squared equals 144. X squared equals 128. So x equals plus or minus the square root of 128, which is 11.314. But I cannot have a negative side of a house. And rounded to the nearest tenth, that would give me that it is 11.3 feet up the side of the house. So picture not drawn to scale. All right, number 19. The flagpole shown is supported by 2 wires. Use the Pythagorean theorem to approximate the length of each wire. So I have my right triangle. X is my hypotenuse. Here's my height right here. Here's the other side. So that's going to give me 8.5 squared plus 15.1 squared equals x squared. So put those in your calculator and you'll get 300.26 is equal to x squared. Take the square root of both sides and x equals plus or minus 17.328. Again, cannot be negative. So the length of each wire is going to be, so I think I did 17.3 feet. All right, 2 more, and we're done. The diagonal of a square backyard is 38 meters long. To the nearest meter, how long is the side of the yard? So I'm going to draw my square. My diagonal is 38 meters. I'm looking for each side. So we've set one up like this before. That's going to be x squared plus x squared equals 38 squared. 2x squared equals 1,444. X squared equals 722. Take the square root of both sides and x equals plus or minus 26.87. To the nearest meter, the side of the yard is 27 meters. All right, last one. A square is drawn in a circle so the vertices touch the circle. All right, there's my circle. There's my square in it. The radius of the circle is 11, so I know that that distance is 11. And if I keep going, then I have another 11. And each side of the square is x. So to solve that, that's going to be x squared plus x squared equals 22 squared. 2x squared equals 484. X squared equals 242. And x equals plus or minus 15.56. Find the perimeter. Perimeter of a square is 4 times the length of the side. My side can't be negative, so that's going to be 4 times 15.56. And that's going to give me 62.2 centimeters. And that's all we have for the Pythagorean theorem. I hope y'all thought it was easy because you've done it before. Thank you so much for watching, and y'all have a great day.